In this video, I'm going to show you how to determine whether a function is even, odd, or neither. And in order to do that, what we're going to do is we're going to plug in a negative x into the function and see what the result is. So when we look at even functions, so let's use the example y equals x squared. That is an even function. If we plug in positive 2, we get the result of 4. If we plug in negative 2, we also get 4. So that means that the function is unchanged. Okay, so when negative x goes in, we get the same answer as we would if we plug in positive value for x. All right, so that means what's happening is we have y-axis symmetry. Okay, so it's reflected about the y-axis. For an odd function, if you plug in negative x, you actually come out with the opposite of the original function. So for example, here when I plug in x equal 1, I get 1, but when I plug in x equal negative 1, I get the opposite of that, negative 1. Same thing with 2. 2 comes out equal to 8, but negative 2 comes out equal to negative 8. So when that is the case, odd functions are symmetric about the origin. All right. Now, there are some cases where it's neither. So if you have some signs that change and some signs that remain the same, so if you have a mix in it, that means that it's neither, and we're not going to be able to determine a y-axis or origin symmetry if that's the case. Okay? All right, let's look at some examples. All right, in our first example, we're looking at f of x is equal to x squared plus x. So to determine whether it's even, odd, or neither, what we're going to do is we're going to plug in negative x into the function. So if I plug in negative x, I would get negative x squared plus negative x. And what we want to do is we want to simplify this. Well, what is negative x squared? Well, that would come out to be positive x squared because we'd have a negative times a negative. It's inside the parentheses there. And then this would remain negative x. So what we want to do is we want to look at each term. Did each term come out to be the same as the original or opposite to the original? If it's a mix of both, that means it's a neither. So in this case here, my original had a positive x squared. My new function, when I plug in negative x, has a positive x squared. So that's good so far. But then my original function had positive x, but my new function has negative x. So part of it stayed the same, but part of it went to the opposite. So in this case here, this is neither, so we can't determine symmetry from using this type of test here. Okay? All right, let's try another example. All right, in this example, we have x cubed plus x. So again, we're going to plug in negative x. So I sub in negative x for x, so I get negative x cubed plus negative x. Negative x raised to the third power would come out to be negative x to the third plus negative x. Okay, so now we look at each term. The first term came out to be the opposite from the original. The second term came out to be the opposite. So both the first and second term changed to the opposite all the way through the function. So it wasn't mixed, didn't stay the same for one and was the opposite for the other. It was opposite for both. So this would be an odd function, and this would have symmetry to the origin. So this would have origin symmetry. All right? Let's try another example. All right, in our next example, we have f of x is equal to x to the fourth plus x squared. So again, I'm going to plug in negative x. So if I plug in negative x, I would get negative x raised to the fourth plus negative x squared. When I have negative x to the fourth power, I'm going to have a negative times a negative times a negative times a negative, which would come out to be positive. So I'd get x to the fourth. If I have a negative x squared, again, because it's an even power, this would come out to be x squared. Now, if we compare the original function to the new function, it stayed the same as the original. So that means that this is an even function. So it's even and it has a y-axis symmetry. All right, let's try another. All right, in this next example, we have f of x is equal to negative x to the 7th plus x cubed plus 5. All right, so we're going to plug in negative x, and we would get the opposite of negative x raised to the 7th plus negative x to the 3rd plus 5. So my negative x to the 7th would be, since it's an odd power, it would come out to be negative, but I have my negative out front, which is taking the opposite. So this would actually wind up being positive x to the 7th, odd power, so this would be minus x to the 3rd, and then we would have plus 5. Okay, so let's see what's happening. So we went from the original was minus, the first term's positive. The second term went from positive to negative. Okay, so we've done the opposite of the original for the first two terms. All right, but look at the last term. Since the last term is a constant, that stayed exactly the same. So that stayed positive 5. So that means that this is not an odd function. This would have to be a neither function because of that last term. Okay, all right, let's try another one. All right, in our last example, we have f of x is equal to x to the 8th minus x to the 4th plus 5. So we're going to plug in a negative x again. So we would get negative x to the 8th minus negative x to the 4th plus 5. And negative x, since we have an even power, this is going to come out to be positive x to the 8th. My negative x to the 4th here is positive x to the 4th, but I have my negative out front. So that's going to make it negative x to the 4th, and my constant remains the same, plus 5. I go and I look at the original. The original function is the same as my new function when I plug in negative x. So that's going to mean even, and we have y-axis symmetry. All right, so I hope that video was helpful to you if you're practicing even, odd, neither functions. Thanks for watching. Please like and subscribe.